Udah waktu.
Good evening, guys. Please turn on your cameras.
Good evening, ma'am.
Good evening, ma'am.
All right. Still cameras are not on. How many times I have to beg you guys, to turn on the cameras, बच्चे? Abhijay, Aditya, Joynil. Yuvraj, can you explain what are electromagnetic radiations? Can you explain once to me, to the class?
Ma'am, electromagnetic radiations. Ma'am, electromagnetic radiations are radiations which can travel in any medium, which do not require a medium to travel.
They do not need a medium to travel in. What else? Arinja, your health is fine?
Yes, ma'am, it's much better. Ma'am, they have a magnetic and an electric component.
And Grishma, complete it. Complete what she said.
I don't know.
You don't know?
Ma'am, I didn't go through it.
Sorry, what?
Ma'am, I didn't go through it, ma'am.
I can't understand what you're saying, Vijay.
Ma'am, I didn't go through it yesterday.
This has been taught 3 classes ago. Ashyash, please complete where Arinja ended.
Ma'am, electromagnetic radiations are emitted by
accelerating charged particles.
She said they have a magnetic and an electrical component. Bhavesh, complete what she said.
Ma'am, I am having another definition. Can I proceed with it?
Okay.
Electromagnetic radiation is the energy that travels and spreads out an electromagnetic wave. These waves are made up of oscillation of electric and magnetic fields.
How can you use the word electromagnetic wave within the definition?
Yes, ma'am.
Anji beta, what are you saying? Joining?
Ma'am, how do you use the word itself within the definition? Like that does not make sense.
I started with electromagnetic radiation is the energy that travels.
Okay. Joining, why don't you complete his sentence?
No, like I heard something in the middle and okay, you know what, never
Okay,
mind.
you give your definition. Leave it.
A source of energy or a self-propagating wave that can move through space, which travels perpendicular to the direction of energy transfer.
You did not say it has a magnetic component. It has an electric component. You did
वो
not
तो हो
complete
गया,
that.
तो that's why I skipped that part.
Okay. They are perpendicular to each other and to the direction of propagation, right, Srijani?
Yes, ma'am.
What is
The
a
magnetic-
spectrum? Gaurangi will tell.
Ma'am, spectrum is the range of different frequencies and wavelengths.
Continuous range. You have to use the
Yeah.
word continue, right? Grishma, I'll come back to you again. Do you know the components of electromagnetic radiations? Please state. Okay. Abhijay, where are you? You tell me the components, please. Please tell me the components.
I won't be telling it in the chronological order, but the UV rays, infrared rays, the visible spectrum region.
Why have you not done it in order? It's just 5 to 6 names. Anybody who has it in order, please. Ishan. Abul.
Gamma rays, then
Be quick, yeah. Come on.
I'm not sure what comes next. Is it X-rays?
Gamma rays and then X-rays. Then
Yes, ma'am. And then visible spectrum.
UV भूल गए. You forgot UV.
Ma'am, the
UV,
order.
then visible, then Himanshu, complete after visible. चलो. देख के नहीं बोलना, सामने फोटो खुली हुई है.
Gamma rays.
गामा रेज एक्सरेज हो गया सब. सुनते नहीं हो तुम क्लास में? आगे बोलो. विजिबल के बाद चलो.
Infrared. UV.
What? Sorry.
Ultraviolet.
वो भी हो गया, विजिबल भी हो गया. आगे बढ़ो.
और याद नहीं आ रही मैम.
हो गए क्वेश्चन सॉल्व ऐसे ही. Aditya, why don't you tell me why atomic spectrum is a line spectrum? Tell me.
When you pass electromagnetic rays onto like a metal and the
You need to come
electron-
closer to the microphone. You are not audible to me.
Yes, ma'am. Because there is the emission spectrum and the absorption spectrum, and like in the emission spectrum.
Can you all
there are
just
different
draw the
frequencies.
atomic spectrum of an atom emitting 2 lines? Can you draw the emission and the absorption spectrum? No need to color it, but just explain it to me. Can you draw and tell? Quickly pick up your pencils and draw it, please. Let me see what kind of knowledge everybody is getting from here. And Dave, can you explain the photoelectric effect for me afterwards? First draw and then explain. Okay? Come on.
Can you please repeat what we have to draw?
Ma'am, pardon. What should I explain?
You should explain the photoelectric effect to me. Okay.
Okay, ma'am.
Can
Beta,
you
if there is an emission spectrum of an atom emitting two lines, can you draw that? Can you draw that? Absorption and emission banao for that atom. Beta, come on.
Ma'am, I've done.
And just raise your hands if you have done. Raise your hands. Okay. Not without that.
Ma'am, excuse me.
On, everyone.
Ma'am, basically we have to draw the emission spectrum of two lines.
Absorption and emission both. Draw karo. Show me how it looks. Small two rectangles, small, this much small you draw and then you show. Dhruv, can you show it to me yours, beta?
Ma'am, I didn't understand the question.
Okay. Instead of drawing it, Dhruv, why don't you tell me what is an absorption and what is an emission spectrum? Can you tell? Can you explain? How do you get it? Explain the process. Walk us through the process of obtaining a spectrum.
I'm not sure about it.
Srijani will explain. Srijani, bata.
In emission spectrum, when we have an excited sample and it emits certain wavelengths, if we observe
How
that
do you excite a particular metallic sample, beta? How do you do it?
ma'am, by irradiating with electromagnetic radiation, and then
So
when it
all
emits,
of them will be absorbed.
no,
All of
ma'am,
them will be absorbed.
two
So let's.
specific wavelengths which will be required for the excitation of electrons will be
What
absorbed.
happens to the rest of the wavelengths?
Rest is either reflected or it's transmitted and converted into heat energy. Now, when we
Good.
observe the emission spectrum, then we will see two bright lines which will correspond to the wavelengths required for excitation of electrons, and the rest of it will be black.
Perfect. Perfect. See, there is all these, some virtues are there in some people, other good virtues are there in other people. Somewhere down the line, you will realize saying exact keywords is very important. She has said many keywords, two lines, right? Otherwise, continuous spectrum has two lines which are not there in the absorption. They are noted in the emission spectrum, right? For either reflected or transmitted and converted into heat. This, you have to do all this. You have to explain like this, okay? Some basic keywords are there. You must know, and that comes by reading, right? So read the NCERT, very important. Correct? Photoelectric effect, Dave was about to explain us.
Ma'am, can you hear me?
Yeah, I can.
Ma'am, so the photoelectric effect is the reaction of the absorption of light, mainly ultraviolet light. Or the visible light, and it excites the molecules and it will react, and it will change their physical or chemical properties.
Can anybody else just add on to this, please?
Photoelectric effect is a phenomenon where electrons are ejected from the surface of a metal when light of a certain frequency hits it.
Yes. So, Why it is a specific wavelength that has to be used for photoelectric effect? Can someone tell? Ashrayash, can you tell?
Why specific? What?
Why do you need a specific wavelength for every single metal? I thought before I go to the derivations of, Bohr model, I should check what we have learned till now. No? See?
May I try?
Who said, can I try? Srijani.
Yes, ma'am.
Beta, go ahead.
Ma'am, in every metal, since the atomic number, the number of protons and electrons will be different, then the electrons will be bounded to the nucleus by a different amount of energy. So different amount of energies will be required to abstract the electrons, and hence every metal will have a specific threshold frequency. So the emitted, the wavelength which is, or the radiation which is given should cross that frequency, threshold frequency.
Okay. What is the rest of the energy converted as? Yuvraj, can you just put some light on that? What is the rest of the energy used as? Obviously, you will give energy which is more than threshold frequency or the work
The
function, right?
energy is converted either at heat energy or the kinetic energy.
The kinetic energy. Can someone tell the Einstein equation? Grishma, you tell. Today you are not saying anything or saying wrong only, huh? What is wrong? You stopped studying so soon.
No, ma'am, not like that.
You are my bright child, yeah. What are you doing?
Ma'am, the equation is E is equal to E naught plus kinetic energy, or we can also write it as H nu is equal to H nu naught plus half mv square.
Half mv square. Okay. So, now next in the line of particle nature, when we observe particle nature of light, we have done black body radiation, we have done photoelectric effect, we have done absorption, the atomic spectrum, which is the line spectrum. Now, fourth thing is your H atom spectrum. We will do that today. We will start that today. But for that, we need a formal introduction to the Bohr's model. Only then we'll be able to move to the H atom spectrum, right? So formal introduction to Bohr's model. How many people know basic Bohr model? Who will tell me? Aditya, you want to tell? You've also been saying wrong things today. Aditya, stop studying. छोड़ दिया पढ़ना लिखना. See, again and again, I keep on telling you that this is a marathon, okay? It is not one day cricket. It's a marathon. It's a test match lasting for 2 years. So one day you study more, another day you study less. This is not how it's going to go. It has to be continuous, just like the electromagnetic spectrum. No stoppage in between at all. You can feel whatever you want to feel. Sad, happy, angry, jealous. I mean, it's fine by me. For anyone. But your preparation should not stop. It should not stop. Work has to go on all the time. It doesn't matter how you're feeling. I'm sorry to say this, but you can express your feelings to someone close by. If you feel I am worthy of it, you can call me and talk to me. Everything said and done. Work should be completed better. Studies should not get affected. And today I am seeing everybody after class 10th result is a slack string. Stop studying, huh? क्या करना है? Let's enjoy. ऐसा ही लग रहा है मुझे. Is it so?
No, ma'am.
See, very soon
No,
I want to
ma'am.
start giving advanced questions. But this class is not, again, some people are studying, some people are not studying. Please make sure you're on the track all the time. Especially in my class. Nobody in my class can ever quote that ma'am does not ask me. If there are 16 people, 15 people here in the class, I will ask everybody. Everyone I will ask. No student is left out in my class. You have to sit with full preparation in my class. Okay? Okay, with no excuse whatsoever. I don't take excuses anyways. And it is not because I am Not like that. I'm like this with you guys. I'm like this at home also. I generally don't take anybody's excuse. If something has been told by me, so it has to be done. Because I apply the same rule to myself also. If I promise something, I'm 100% going to, either I don't take up that thing. If I take it, then it's 100% done. If I know I can't do it, I will straight away, so ye nahi ho paega mujhse, I will not do it. So many things. I have single-handedly managed so many projects in my life. Say, I'm able to do, I will do it, no problem. Please make sure that this project is your own baby, okay? You chose science. Your mummy daddy did not. You have to stick to it. You have to. There is no other way out. Understood or not, beta? You have to do justice to it. What all do you know about Bohr's model of an atom? Who will tell?
Ma'am,
Ma'am,
can I?
may I say?
हाँ अरिंजा बोलो.
Ma'am, he was the one who stated that there are specific orbits around the nucleus in which electrons revolve.
Can someone tell how is it different from Rutherford's model? I had stated this in some previous class also.
Ma'am, Rutherford model was not able to explain the electromagnetic wave theory, which means that the energy cell, if an electron will revolve around the nucleus, it will lose its energy. But Bohr said that if an electron will move around the nucleus, it will move in a specific energy cell.
So how is this specific energy shell different from what Rutherford said? Can you can you show light on that?
Ma'am, he just wasn't able to prove it, which is why his model was like kind of
Ma'am,
lacking.
Rutherford did not explain why it's not falling into the nucleus or did not make a statement as such, but Bohr made the statement that electrons, when they are moving in specific orbits, they will have specific energy. They are not going to lose energy and fall into the nucleus.
See, Bohr made it very, very clear. He made it very clear that an electron does not have energy. It is the orbit which has energy, which is at a specific distance from the nucleus. Okay. Rutherford said charge particle hai, it will have energy. It will lose energy when it gets closer to the nucleus and it is ultimately fall into the nucleus. Correct? Bohr he changed the whole story. He said electron doesn't have energy. It's like holding the air from here or from here. बात एक ही है. It's just another perspective of the thing. Listen carefully. Rutherford said, electron has energy, it will fall into the nucleus. The existence of atom will end. Bohr said, listen, the electron can go into any level. It's the level which has energy. Because each level is at a fixed distance from the nucleus, it will have certain energy. Goes away, lesser energy, right? Are you getting my point? Technically, it is the same only. So he said, whichever level the electron falls into, it will have the energy of that, but assigned to that particular level. Also, as Arinja said, very important thing, he fixed everything. There are fixed orbits around the nucleus. Right? So there are, with a theory, there exist postulates. So we will write down postulates of Bohr's theory. Postulates of Bohr's theory. One second. Okay. So the first postulate is number 1. Fixed levels. Fixed levels. So not only were the orbits fixed, he said position, energy, velocity associated with an electron are fixed. All these virtues are fixed. One can understand how impossible it is. How? The mass of electron is 9.1 into 10 raised to power minus 31 kilogram. Velocity we will derive together. It is 2.16 into 10 raised to power 6 meter per second. We will derive, don't worry. Okay. Imagine this particle traveling with this speed, has a fixed path, has a fixed position. When fast bowler balls, and then sixer is there, and if somebody catches, umpire does this. What is this? Third umpire. He cannot see. So that is naked eye. So we will say, madam, we will use electron microscope. You will. But do you think you'll be able to fix a position for electron revolving with this much speed, with this much amount of mass? It is impossible. Now that you know it and you look in hindsight, you obviously can understand this is crazy. This is absolutely crazy. You cannot figure this out. Okay, it's very difficult. So all these fixing of levels is just not done. So first postulate also you can easily understand that it is not everything is going correct here. Okay, let's go to the second one. Quantization of angular momentum. Quantization of angular momentum. Niels Bohr stated that the angular momentum associated with each orbit is quantized and is a multiple of, I'll explain everything, multiple of h upon 2 pi, which is a constant because h is the Planck's constant, right? We all know that. 2 pi is also constant. Now, can all the great physics people here tell me what is momentum? This you studied from class 9, so you can't say
Mass into velocity.
Mass into
Yeah,
velocity.
that I also know, yeah. That I also know. It's mass into velocity. What is the physical interpretation of momentum? Linear momentum, linear, not angular, linear.
Ma'am, it is derived from the concept of impulse and Newton's third laws.
So I'm
As in-
talking about the physical explanation of it. What do you infer from a body having a certain amount, magnitude of momentum? What is that?
Ma'am, the amount of motion contained in a body.
Perfect. Beautiful. Amount of motion contained in a body. Yes, 100%. In a body is momentum. Now this is linear momentum, na? When it is traveling in a straight line. What is angular momentum?
When traveling in a circular path.
When traveling in a circular path, the momentum which is associated with a certain particle. Now, you know, a circle is a collection of particles and where direction is continuously changing, right? And you find the direction of any particular, the point existing at any particular point with respect to the tangent, which is perpendicularly drawn, right? Tangent is drawn, right? Right. And this R component becomes very important, right? There can be smaller circular paths. There can be, longer circular paths, right? With a large amount of radius, right? So they will change the amount of motion which is contained in that body, which is traveling in a circular motion, correct? Circular path. Okay. So m into v is linear momentum. If it is traveling in a circular path, what change should be brought into this formula, bete?
Ma'am, we have to multiply it by r radius.
mv, and you know it is changing direction every single time. So it's a cross product, right? Vector, right? So can I say mvr sine theta? Now here that theta is 90. mvr, what is sine 90?
1.
You all know about it, right? mvr into 1 is equal to mvr. It's angular momentum associated with an object which is traveling in circular path. Now Bohr said this angular momentum is a multiple of this constant and n multiplied by n. When you multiply by, now n is a whole number, positive whole number. Now n represents the orbits around the nucleus to which Bohr has assigned energy levels, right? That is called the energy that Bohr called as energy levels. N is that. When we say that angular momentum is a multiple of h by 2 pi and it varies only with this, which can be 1, 2, 3 positive whole number. It means that it is quantized. That means it is a whole number multiple and we keep on changing. So for n is equal to 1, mvr will be equal to 1 into h upon 2 pi. Do not cancel out anything, okay? Do not cancel 2 by 2 pi, no. Just let it be like a multiple, okay? For n is equal to 2, mvr is equal to 2 into h upon 2 pi. Correct? For n is equal to 3, so on and so forth, mvr will be equal to. This is called, this process of multiplying by a certain amount of number into a fixed quantity, into a constant quantity is known as quantization. Quantization. This is called quantization. Quantization. Multiplying a particular constant with a fixed number is called quantization. Okay, beta? Not a problem. Not a problem at all. Yes.
No, ma'am.
Mom, can you repeat once again?
Beta, this is a constant. I am changing the orbits. This is what you learned in class 9. When you change the orbits in a Bohr atoms, it can be Bohr model 1, 2, 3. So if I multiply a fixed quantity, right, with the changing orbits, the angular momentum of those orbits will be quantized based on multiplication by the orbit number. When you do that for a certain quantity, this process is called quantization, multiplying by a constant figure and according to the changing energy levels of a particular atom. Okay.
Okay, ma'am.
I can do this. We will do this later also with many things. For quantizing a particular, physical property, when you multiply with a constant and you change certain numbers, that is nothing but quantization. Fixating those levels of that particular, where that particular electron exists. Am I clear over here, Vijay? You have fixed the level.
Yes, ma'am.
Okay, whenever n is equal to 2, so it will be 2 into h by 2 pi. Nothing else. It cannot have any other value. Yeah?
Okay, ma'am.
Yes, ma'am.
So this depicts a certain, when n is 2, so you can understand that, that radius mvr, this will also increase now, because orbit is now far from the nucleus as compared to n is equal to 1. So accordingly, angular momentum will change. You understand? Angular momentum will change now accordingly. As when the orbits will change, angular momentum will also change. Okay, this is quantization of electronic levels of where the electrons exist in a Bohr model. Postulate number 3. Bohr called the orbits as stationary levels and also pointed out that it is these energy levels or these orbits which have a different value of energy. Electrons occupying a certain energy level will have the energy associated with that level. With that level.
Can you scroll up?
Yeah. Yesterday, I had given one question to Himanshu and Jitesh about the variation of energy with lambda and this kinetic energy. Have all of you done it or not? Himanshu, have you specifically found it out? Jitesh, though, is absent.
Yes, ma'am.
Others, you have done it?
Yes, ma'am.
Bhavesh, next time will you remind me to discuss those two things on Thursday? I don't wish to go back to that right now. At the start of the class for 5 minutes, we'll discuss, okay?
Okay, ma'am.
Excuse me, ma'am.
Yes, beta.
Ma'am, so what you wrote is that electrons occupying a certain energy level will have the energy associated with that level. So, ma'am, are you saying that the electron's energy is changing?
Yeah, when the electron gets excited to higher level, what will it do? Will it still carry the energy of the previous orbit? No. It will have the energy of
Ma'am,
the
but,
orbit to which it belongs.
ma'am, but then, like, isn't one of the postulates saying that electron's energy doesn't change, but then it does just moves from a higher stationary state to a lower stationary state?
So it will have the energy of that stationary state. That's exactly what I am also saying. The energy of the electron will be the energy of the orbit to which it belongs. That's what this postulate means. Okay. And they are stationary. They are not changing. The electron goes on moving. If it is provided energy, it absorbs energy, goes to a higher level. Now that higher level's energy will be that of the electrons. Now that electron, when it comes to the lower energy level, now the electron will have the energy of the lower energy level. Okay. Whatever it is, whatever the magnitude of energy associated with that level is. Got my point, beta?
Okay.
Now it's clear? Beta.
Yes, ma'am.
Okay. Now fourth is an electron can stay in its particular orbit or energy level only if centripetal force is equal to electrostatic force. We have already discussed a lot on this, correct? You remember, you guys? I had discussed about to stay in a particular orbit. The centripetal force has to be equal to the electrostatic force. Now the centripetal force is mv square by r. Okay. The electrostatic force is represented by 1 by 4 pi epsilon naught is a constant into Q1, Q2 by R square. What is Q1? Let it be number of protons having the charge E 1.602 into 10 raised to power minus 19 coulombs. So can I say Z, the total number of protons into E will be the Q1? Only one electron, which is right now in consideration.
Can you scroll up at the definition?
What is the value of that constant?
ले रहा हूँ मैं रख दो
Up at the definition of fourth postulate.
Oh.
Excuse me, ma'am.
Yeah, yes.
Ma'am, what is the value of that constant?
Epsilon naught, I will tell.
What?
Wait, I will tell.
Okay, ma'am.
Permittivity in free space. Okay. Noted. Can I go ahead, please? Now, can I say mv square by r is equal to 1 by 4 pi epsilon naught into ze square? Because Q2 is E, Q1 is equal to Z into E by R square. Mark this as equation 3, the top as equation 2, this one. And this as equation 1, ये वाला, this one. Okay. Quantization of angular momentum as equation 1. The basic equation equalizing centripetal force and this one, electrostatic force as equation 2. And the third one is this, the simplified version of the above one, equation 2. ठीक है बेटा?
Yes.
Squaring equation 1, we will get m square v square r square is equal to n square h square by 4 pi square. 4. Got it? Find out an expression for r, which is the radius of a Bohr's orbit. Shall we? Find it out, beta, quickly. Everything on the right hand side, only r on the LHS. Quickly.
Good evening, Pradeep. हाँ.
Ma'am, excuse me.
Yes, beta, done.
Ma'am, can we substitute the value of V from first equation and then put it into third equation?
Sorry.
Ma'am, can we find out the value of V from first equation and put it in
Why
second?
would you get V square is going to cancel out, beta. They're going to cancel out, no? 3 and 4, see?
Ma'am, from second method I am telling, alternative.
मुझे V चाहिए ही नहीं equation में. I don't need V in my equation. I need an equation for R.
Okay.
I don't need V.
Can I
V
try?
करूंगी मैं अभी. हाँ, tell me.
Xylem not into n square h square by pi into.
You have to be a little louder today. I cannot hear you much. I think there is your microphone, or maybe my ears are gone.
Ma'am, R equals xylem not into n square h square by pi into.
Wait. N square and Z are going to change, right? For every single atom. Number of protons change for every atom. N square changes. That depends on which orbit. You take it out of the bracket and rest are constants. They will be inside the bracket. Now say. N square by Z?
N square by Z into.
Huh?
Xylem naught into h square.
Epsilon naught. Epsilon.
Sorry. Okay. Epsilon naught into h square by pi into e square into m.
Is everybody getting this?
Yes,
Ma'am,
ma'am.
I'm getting the
Yes,
root
ma'am.
of this, the exact same thing.
Beta, exactly you have to get this only. Everybody will get the same thing only.
Yes. I'll see. I must have made some problem.
This is the beauty of maths. Everybody gets the same result. Arinja, ठीक हो जा पहले पूरी तरह. You don't look well to me today also.
I did drink the.
No, did you have
God,
momos
no.
along with it? कुछ नहीं पता. उसके साथ momos
No,
खाओ मैं तो ठीक हो जाऊंगी.
ma'am, I'm so puking now. I've started puking, so I'm not able to get anything.
What did you eat actually? खाया क्या था ऐसा इतना बुरा?
Ma'am, I don't know. It's probably because it's really, really hot also. So that also.
Where are you living? Where are you living?
I live in Ranchi.
हाँ तो आम पन्ना पीने का ना.
ओ
दिन रात
मैम
आम पन्ना
वही पीने से हुआ.
ए चुप कर. कहाँ से बाहर से लिया था कि
प्लीज
घर में बनाया
नहीं
था?
नहीं घर में बनाया था. वो पता नहीं उसके कोई तो उसमें मसाला या फिर आम. I'm telling you ma'am, it was that only. I drank that and then I started puking.
Oh, I don't know. Okay. It suits me a lot. I mean, I don't have, I just drink more of desi drinks. Okay. So now can you see that these are basically these are constants. Okay. These are constants. So this constant is equal to 0.529 angstrom or 52.9 picometer. Okay, which is 0.529 into 10 raised to power minus 10 meters or 52.9 into 10 raised to power minus 12 meters. So your radius basically comes out to be R is equal to n square by z into 0.529 angstrom. Because obviously length ka unit hai, it is a factor of length. Okay, now this or R is equal to n square by z into 52.9 picometers. Now, if I told you to calculate for RH, right? So for H is hydrogen atom. Hydrogen atom means it's a 1 electron system. ठीक है बेटा? It's happening to my handwriting and my pen both. N is equal to 1 and Z is equal to 1 proton and first orbit, right? So RH is going to be just 52.9 picometer. 1 square divided by 1, yes? Correct, na? Sahi hai? Everybody is getting what I'm trying to say?
Yes, ma'am.
Yes, ma'am.
Or 0.529 angstrom. Clear or not?
Yes, ma'am.
Just for one orbit of hydrogen atom or for like the whole?
It's the first orbit at the because an electron is contained over there only, na? I have not gone to electron exciting to another levels. Just for one electron system with one proton, what is the radius where the electron originally exists for a H atom? Clear? Yes. I am giving you a homework and I expect each one of you to do it till Thursday. Okay? What you will have to do is, now, this is RH. Okay. So if I say you have to calculate radius of H atom for these n levels. Okay. So just look at one of the examples I'm going to do. N square by Z is equal to 1 will be 4 into RH. So R N is equal to 2 can be represented as 4 into RH. Am I correct?
Yes, ma'am.
Yes, ma'am.
This is rest you have to fill. Okay. Look here, beta, look here. Next, what you have to do is you have to take HE plus iron. He plus is 1 electron system. Bohr only was able to explain for 1 electron systems. So I will take ions that like that only. Now for this, Z is equal to 2. Okay? Z is equal to 2. So N is equal to 1, N is equal to 2, N is equal to 3, N is equal to 4. You'll be able to do it?
Yes, ma'am.
I need this table till tomorrow. You will observe that we will make 4 or 5 tables like this in the next class, next 2 classes. You will observe that these will encompass nearly 30 to 40 questions in N-Avasthi. Table is in front of you. You don't have to do any kind of extra work if you have this table with you. Okay. I am just eliminating all the hard work that has to be done for individual questions. Table is right in front of you. Just open your notebook, glance through it, you'll be able to do it. Or rather, don't even do those questions because you already have this data over here. Just remember that n square by z into 0.529 angstrom का formula. Get my point? फिर आपको क्या करना है? Li 2 plus z is equal to 3. You will thank me later because you've drawn this table. When exams are about to approach, now you will thank. Okay, ये तो करा हुआ हमने. This is easy. For Li 2 plus, z is equal to 3. For Be 3 plus, z is equal to what? 4. N equal to 1, N equal to 2, N equal to 3, N equal to 4. Every single student has to do it, and I will ask every single student each one of the things. Okay, got it or not?
Till which atom we have to do? Till beryllium only?
Whatever I have written, you have to do only till that.
Okay, ma'am.
You can go and open N-Avasthi and you will see so many like this. So many questions are there based on this. Just draw this table. Same table we will draw for velocity also, kinetic energy also, potential energy also, total energy also we will do. Okay. You will be at a much better place next week because you would have finished all these tables and those questions, 50, 60 questions also done. Not a problem. Yes. But make sure you draw the table because I just want you to focus on difficult questions rather than just multiplying 2 by 2, divide by 2. This is just have a table which is right. I don't want you to fret over mathematics over here. Right. Just get the concept, get the things understood. That's all, and move ahead to difficult ones. Move ahead to advanced level questions. Level 2, level 3 type questions. Okay. Fine.
Yes.
So, yes, we will meet on Thursday again and we will continue with this table. Everyone in my class will do this table. Table, bina ki class mein mat baithna, please. Because it just dilutes the whole purpose, you know. It really does. When everybody is doing the things together, that's where the fun is, right? And today I told you like this, like today things happened and somebody is answering vague, somebody is not answering, somebody is answering full. No, theek hai. Everybody should be at the same pace, beta. Okay, fine. Chaliye, on the count of 3 to 1, everyone. 3, 2, 1. Perfect. Chaliye. I'll see you on Thursday. Bye, guys. Take care.
Thank you, ma'am.
Thank you, ma'am.
Thank you so
Bye,
much.
ma'am.
Bye-bye.
Thank you, ma'am.
Bye, guys. God bless.